this is Rami. I'm starting a new series of videos with the goal of having each video shorter than 5 minutes. Maybe later 10 minutes would be the longest one. So I'll make the topic that I'm gonna go into digestible, and the topic mainly is gonna be about composites, focusing more on carbon material, but also going later on a bit more about glass and other materials of composites. The purpose is to talk a bit about the state of the industry, the state of the art, the technology itself, on how the carbon fibers are made, and beyond that going into how they are assembled, they are weaved together, laminated, and how you produce components made of carbon fiber. But after that, and a bit along the way, I'm going to introduce a bit the topics that I worked on researching during my master thesis, which was related to converting polymers to carbon material, and later on in my doctoral related research, designing composites that have different features that are actually not based on fibers at all. They are focused on two-dimensional reinforcement, or what you could easily call foil-based reinforcement. And that along the way, in the next videos, I'll explain like piece by piece the different topics, the different ideas, the different developments. I'll be mentioning the papers I've published so far. Maybe parallel to this series, I'll have new papers published, and I'll explain every new publication that's related to the topic of composites. And I'm always open for questions. I'm open for discussions. If you have more interest in the topic of carbon manufacturing, composite industry, I'd be glad to answer some of the topics, maybe make special videos about that. However, in general, the goal of my channel has always been to talk about engineering, talk about technology, and talk about my interests and the interests of the times. So what is currently an important topic in technology and manufacturing. In this first video, I will focus on a brief introduction on how carbon fibers are made. Along this description, you'll see some images. Most of them are images I tried to generate with DALL-E 2 by trying to give it a prompt to describe what I'm trying to say and see what kind of images could be generated. Just because those images, I could consider them open for access. They are generated by me, by my prompts, and I decided to use DALL-E to generate the illustrations for my explanation rather than try to find open access images or try to illustrate myself. I hope DALL-E is doing a good job, and if you think it could do better, let me know what other prompts I could test. They're basically produced starting with the polymer. And the polymer is a not so known one. It's called polyacrylonitrile, which abbreviated as PAN, so it's a PAN polymer. It doesn't really melt as good as the usual, most commonly used polymers like polypropylene, polyethylene, or others. And because of that, it needs a special type of processing. It starts as a powder, a very fine white powder, and it is then mixed with a solvent, so it's another chemical that dissolves it, absorbs it. The chemical most often is used as DMF, which stands for dimethylformamide. There are other types that are more, I would say, environmentally friendly and less toxic or dangerous to human contact. Another example is DMSO, dimethyl sulfoxide. So there's a lot of chemistry involved, but the acronyms will help you search if you'd like to know more about it. So there's DMF, most commonly used, DMSO, the second. The polymer PAN is about 80 to 90% of the market of carbon. So the 80% of the market uses that polymer to start and to convert it later on into carbon fibers. After having the powder ready and dissolving it into the solvent material, you end up with a viscous mix that's more or less seems color-wise, fluidity-wise like honey. That liquid is pressed into an extrusion process and pulled out of very small holes into the extrusion die. And this process of extrusion into small perforations is called a spinning process, which is inspired from spiders actually. And this is the way that spiders produce their own webs. They have a specific polymer in the bellies, and by pulling that polymer, they stretch it into thin microfibers, and by pulling it through a small hole, the molecules actually orient. The molecules are mostly parallel to the fiber direction, and that gives the fiber a much higher strength. So after the spinning process, you end up with polymer fibers that are micro in diameter, thick, and about 10 to 5 micrometer in diameter. They usually spin into bundles, so you spin a bundle of maybe 1,000 or more of those fibers, and they are then taken to the next step. Could be in the same facility or in another facility. As soon as you have a bundle of those fibers, a roll of these fibers, it goes to a next facility that uses an oven. The oven has two main phases. The first part is heat at temperature of 300 to 350 degrees Celsius. Depending on different manufacturers and technologies, it could deviate a bit from those values. And in these medium temperature ovens with the oxygen in, the polymer absorbs the oxygen. The oxygen reacts with the molecules and creates some bonds between the chains of carbon, and these bonds are usually called crosslinks because the oxygen works as a bridge between a molecular chain of carbon and polymer and another chain of polymer. So these oxygens sit in between, they hold the chains together, and this reaction allows the polymer to have much higher melting temperature, much higher resistance to heat. At that stage, the polymer is ready to go to the much higher temperature oven, which is usually starting at 900 degrees Celsius, going up to 1500, up to 2000 degrees Celsius. And in that oven, there's no oxygen. The atmosphere is supposed to be inert, usually nitrogen gas or argon gas. And at that temperature, all the nitrogen atom already in the molecule, oxygen atoms, hydrogen atoms, break away from the chain, and you end up with only carbon chains. And these carbon chains held together end up as the carbon fiber itself. So you kind of purify the material, you kick all the other atoms out, and you end up with only the main carbon chains left, and that's the carbon fiber. At the exit of that last oven, the high temperature ovens, the fibers are usually coated with a thin layer of material that is based on epoxy chemistry. That process of coating is in the industry called sizing. That coating has multiple functions, but among the main functions is to protect the fibers from oxidation, from other chemical reactions after processing, to protect them from any damage while handling when these are wrapped again, bundled again, to process further, and to also increase significantly how well the fibers bond to the epoxy later, or to the matrix material later. So later there will be some other material infused between the fibers, and the fibers need to bond very well to that material, so you'll have a significant increase in strength and the component you are producing. That itself is the general process of producing carbon fibers.